Welcome to the explainer. All right, let's talk about a new standard that's supposed to be the one-size-fits-all adapter for AI, the Model Context Protocol, or MCP. The promise is huge, connecting our AI agents to the whole world. But what happens when you give an AI the keys to literally everything? Well, that's where the story gets really interesting.
This line right here from Anthropic, the team that came up with the protocol, this says it all. I mean, think about it. How much simpler did your life get when that one little cable, USB-C, could suddenly charge your phone, your laptop, your headphones, everything? MCP wants to be that for AI.
So what does that really mean, to be the USB-C for AI? It's all about creating a single common language, a common ground, so all these different models and tools can finally talk to each other without a problem. At its heart, MCP is really just a rulebook. It means that instead of developers having to build dozens of different custom-made bridges to connect an AI to, say, Gmail, and then another one for a database and another for a web browser, they just build one. And this isn't just about making things easier, it's about unlocking the ability to build these really powerful, interconnected AI agents at a scale we just haven't been able to before.
And believe me, this isn't some niche idea that only a few people care about. The biggest players in tech saw this and immediately realized that a universal standard was the key to unlocking that next massive wave of AI applications.
I mean, just look at how fast this all happened. What started as this cool open source idea from Anthropic just exploded. In just a few months, it became this cornerstone piece of technology for the industry's absolute giants. That kind of speed, that kind of unified adoption, that tells you something really, really big is happening here. And Sam Altman's announcement, that was a landmark moment. You've got these huge rivals, OpenAI and Anthropic, basically agreeing to use the same playbook. They got that a universal plug helps everybody. It's that classic idea that a rising tide in the AI ecosystem is going to lift all boats way more than any walled garden ever could. Okay, so how does this universal adapter actually function? What's going on under the hood? Well, it's surprisingly simple, actually. It borrows a concept that pretty much powers the entire internet. It all boils down to that classic client-server model. The easiest way to think about it is like you're in a coffee shop. Your AI application, maybe it's a chatbot you're using, that's the customer. And the tool it needs to use, like your email, that's the barista behind the counter, just waiting to take an order.
So the whole conversation is just this simple back and forth. First, the AI client walks up and asks, "Hey, what's on the menu? What can you do for me?" The server, our barista, says, "Well, I can write emails and I can look at your contacts." The client then gives a very specific command, and then boom, the server gets to work. It's this really simple, elegant dialogue that can power some incredibly complex stuff.
So what exactly is on that menu the server can offer? It really comes down to three things. You've got tools, which are actions the AI can take, like actually sending an email. Then you have resources, which is data it can look at, like reading a file. And finally, prompts, which are these smart little templates that help guide the AI. All three together give the AI a rich, interactive workshop to play in.
All right, so this all sounds fantastic, right? Especially when you're using these super powerful models in the cloud. But what happens when developers try to use it in the real world? Say, running models locally on their own computers, maybe for privacy, maybe to save money.
This is where the dream kind of hits a brick wall. One developer trying to run OpenAI's new model on his own machine found this out the hard way. See, your computer's memory has to hold the entire AI model and the whole conversation, including these really detailed descriptions of every single tool that's available. And that space, it gets crowded really, really fast. And just look at this chart. The difference is staggering. On a machine with a small memory limit, a simple prompt barely even makes a dent. But the second you simply enable an MCP tool, we're not even using it yet. A whopping 74% of the model's memory is just gone. Poof, just to load the tool's instruction manual. And what happens when you put that much pressure on the memory? A total meltdown. The model just got confused and stuck in this loop, trying to use the tool again and again and again. It blew past its memory limit by over 1,400% and crashed. It's a stark reminder that while MCP is incredibly powerful, it can be just as demanding on the hardware.
But honestly, memory overload? That isn't even the biggest challenge facing MCP. Not by a long shot. There is a much more serious, much more fundamental issue that has engineers and security folks sounding the alarm. And this right here is where the problem gets really, really serious. We're in this sort of gold rush to connect every app, every database to AI agents. And in that rush, developers are moving so fast and they're breaking things. Specifically, they're just completely ignoring basic foundational security practices. And this is not a hypothetical. This is real. Researchers went out and found nearly 2,000 of these MCP servers just sitting there, wide open on the internet. And of the ones they tested, not a single one required a password or any kind of authentication. That means literally anyone could potentially command these tools to go in and access, change, or even delete sensitive data. So for any developer working with MCP right now, this has to be your new code of conduct. You have to assume that anything you expose is basically public. You have to start with the absolute bare minimum read-only permissions, and you must always require a human being to click yes before any action that writes or deletes data. This isn't just good advice, it's essential to prevent a complete disaster. So, where does all this leave us? We've got this protocol that has the potential to absolutely revolutionize AI agents, but it's completely shadowed by these very real, very scary dangers. How do we balance this incredible power with its built-in peril? I think a key takeaway here is knowing which tool to use for the job. If you're building tools just for your own app, simple function calling is probably the smarter, safer bet. But if you want to build a tool that any AI application on any platform can pick up and use, well, that's where the universal standard of MCP becomes absolutely essential. So in the end, yeah, MCP is definitely becoming that USB-C port for AI. It's creating that single, powerful standard for agents to interact with our digital world. But this tool is still very, very wild. And it leaves us with this one critical question we all have to answer. In our frantic race to build this all-powerful, all-connected AI, are we forgetting to build the locks for all the new doors we're opening?